All right, my beautiful followers, good afternoon and welcome to today's class. In today's class, I want to take you through how to select the right contactor to power your electric motor. In today's class, I want to show you one of the major things you must look out for on your electric motor, and that is your nameplate. This here is the nameplate of this electric motor, and this is where you are going to get all the information that you require in your calculation for the right contactor to drive the motor. So right here, you are going to be making use of this information. This is the power rating of this motor. It is 4 kilowatt. And then the voltage rating is 400 volts. The power factor of this motor is 0.8. And the efficiency of this motor is about 0.9. This is 86.7. This is about 0.9. Okay? So how do we calculate this? First, these are the information we have. We have this information that the power P is equal to 4 kilowatt, and this is equivalent to 4,000 watt. All right? And we also know that our voltage here is 400 volt AC. Of course, this is a three-phase system, and then we're going to have our root 3. And that is, of course, 1.7. And then we're going to also make use of the power factor PF, or cos phi, is going to be 0.8. We're going to make use of the efficiency, and that is going to give us 0.9. All this information, we found them here. All right? This is where we found all this information on the nameplate of the electric motor. So the next thing to do is that we're going to apply the power formula, which says that power is equivalent to current multiplied by voltage. And then current is equal to power divided by voltage. All right. So in this case, what we're looking for is the full load current of this electric motor. You can call it full load amperes or full load current. It depends on where you are. Okay, so the current I is going to be power P over the voltage multiplied by root 3 multiplied by our power factor multiplied by our efficiency. Okay, so putting these things down, we're going to have 4,000 over 400 multiplied by root 3, if we check by our calculator, is going to give us 1.73 multiplied by our power factor is 0.8 multiplied by our efficiency, which is 0.9. And this whole thing is going to give us 4,000. Let me shift this a bit. 4,000 divided by 498.8. All right. So now to get our current here, the full load current, we're going to now divide 4,000 with 498.8, and that is going to give us 8.0 amps. All right, so this is the full load current of our electric motor. Now, for you to now choose the right contactor for this job, you are going to multiply this by a safety factor of between 1.5 and 2.0. So if we choose 2.0 as our safety factor, 8.0 amps multiplied by 2.0 is going to give us 16 amps. So the contactor required to drive our electric motor is 16 amps. But I don't think 16 amps is a standard value for contactors. So the closest to 16 amps is actually 30 amps. I think we have 25 amps. But you are going to choose the standard rating that is above, the closest above your calculated value of your contactor current. So if you have 16 amps, of course, we don't have it. a 16 amps contactor, the nearest one is either 25 amps or 30 amps. So any of these you use, especially 25 amps, is the right contactor to drive your motor. So if you like this video, please let me know in the comment section. If you have any question, you can also let me know in the comment section, or you send me a private message. And you continue to follow me for more tips on power. Thank you very much.